Today we're going to work with operations of rationals and solving rationals. And in order to start doing that, we're going to talk about reducing the rational expression first. Just like you wouldn't leave a fraction as 3/12, you would reduce that to 1/4, you would want to reduce one of these fractions. However, to reduce this rational, you would have to factor. So in our numerator here, we can factor out a -2. And we get -2 times x would give me that -2x, and -2 times 4 gives me that -8. In the denominator, we have a trinomial that I can factor. That trinomial has a coefficient of 1 here, so that's an easy one to factor. We're looking for what multiplies to be -12 and adds to be 1. And so that would be x plus 4 and x minus 3. Now we can reduce this fraction if there is exactly the same factor in the numerator and the denominator. And there's an x plus 4 and an x plus 4. So I can cancel those out to reduce. And so that would be -2 over x minus 3. Now, one of the things we see often is there's an x there and there's an x there and people try and cancel that out. That's a big no-no. You do not want to do that. This is all together and this is all together. So you can't just cancel something out of the middle. That would be a breaking of the rules on the order of operations. All right, on the second one here, we have the difference of two squares. If you have not become familiar with factoring, you need to go back and do that because with rationals, you're going to factor quite a bit. So x times x, and then this is 4 and 2. That top one was the difference of squares. That's one that you will use very often. So you got to be able to recognize a perfect square minus a perfect square always factors to be that. Now x plus 2 cancels x plus 2, and we're left with x minus 2 over x plus 4. And so that's how you reduce one of those rationals. Now let's talk about the actual operations. So we'll start with multiplying and dividing because that's actually the easier one with rationals. Again, factoring is your friend. And in some cases, like this one, you will have to factor 4 times to do this equation. So we need to factor all 4 of these. All right, so now that we have it all factored out, we can start canceling things out. With multiplication, you multiply all of the numerators together and you multiply all the denominators together. So at the end, all of this will be together in the numerator and all of this will be together in the denominator. But it's easier to start by canceling out what you can cancel out already. So if there's something in the numerator and something in the denominator that's the same, even diagonal, you would want to cancel it out. So we can cancel out x minus 1 and x minus 1. Now this one cancels out one of them. It does not cancel out both of them. That's another common mistake we see. Then x squared plus 1 and x squared plus 1 can cancel. There's nothing else that can cancel. Remember, this does not cancel this because all of this is one term. Now we're ready to multiply across. So we've got x minus 1 times 4. And in the bottom, we have x times x plus 2. This is the best way to leave your answer in the factored form. So you want to leave it just like that. That shows that nothing else can be canceled or reduced. Now, when we do multiplication, division, adding, subtracting, and solving, you do want to cancel out any possible x that would make it undefined. This cannot be 0 since that's a plus 1. So that one's okay. But this one right here, and it's a squared term, sorry. This one right here, -2 would make that 0. 0 would make this one 0. And a +1 would make that one 0. So we would have wanted to restrict our x values to anything but those 3, the -2, the 0, and the 1. All right, for division, your middle school teacher probably taught you keep, change, flip when you were doing fractions. That's the same thing we're going to do here. We're going to keep our first one, we're going to change our division to multiplication, and then we're going to flip the second one to look like this. So I'm going to go ahead and factor while I do that. So I've got x plus 4, x minus 2 over x plus 4, x plus 3 times x plus 1. Then I'm going to change that division to multiplication. And then I'm going to flip the other one while I factor as well. So that x minus 2 is going to come to the bottom. And this one here, we can factor out our greatest common factor of 3. So we get x plus 1. Now it's just like multiplication. If there's something in the numerator and the denominator, it cancels. So x plus 1 cancels x plus 1. X minus 2 cancels x minus 2. And we're left with x plus 4 over x plus 3. For my restrictions, what can x not be? X cannot be -3 because that would make that 0. X can't be -1 because that would make that 0. And x cannot be 2. We would also list if something up here would make it 0 because since we flipped, it would make it undefined at this point. Since we've already listed that as -1, we don't have to list it again. So that was multiplying and dividing. Adding and subtracting is the harder one. And that's because if you remember doing fractions, you have to get a common denominator. So we'll have to get a common denominator for these as well. Now in this first one, they did give us our restriction already, which is nice. So our denominator cannot be -5/2. They do have the same exact denominator, so we're ready to go ahead and start adding. We'll start with that. So when we add and subtract fractions, we keep the denominator. So we're going to keep 2x plus 5, and then we're going to add our numerators. 2. When we do that, we're combining like terms. So 2x squared times no other one will be 2x squared. We only have this x, so that'll be x. And then a -4 plus 3 is -1. I went ahead and factored that. So that's 2x minus 1 times x plus 1 in the numerator. The reason why we factor this is to see if it can reduce further like we did up in the top. This cannot reduce any more, so that would be our answer. You want to leave it in that factored form showing that it does not reduce any further. All right, now we're going to try a subtraction one. Again, this one already has a common denominator, so we keep that denominator of x minus 3. And we're going to go ahead and subtract our numerators. And you do have to subtract this entire thing from this one. So this one's a little bit trickier. That's x minus 3x, which gives us -2x. That's the one most people remember to do. The one they forget to do is this one. You are subtracting that 2 as well. So this would be 0 minus 2, which is a -2. Again, I factor to see if it reduces any further. And sometimes they're not going to factor, but these did factor up on top. And so we factored it, nothing cancels. And so we just leave it like that. All right, now we're going to talk about the ones that do not have a common denominator. There we are. These two do not have a common denominator. So the first thing we would need to do is get a common denominator. You cannot add or subtract fractions without a common denominator. For this denominator here, I need an x plus 4. And for this one, I need an x minus 2. Here is our new least common denominator. The x plus 4 goes into that one, and the x minus 2 goes into that one. Now, to get from this first denominator to this one, I multiply times x minus 2. I can't just do that because it's changing the value. So I'm going to have to multiply the top times x minus 2 as well. For the second one, to get from this denominator to this new denominator, I multiply times x plus 4. Whatever I do to the bottom, I need to do the top, so I'm not changing the value of the equation. Now, before we can subtract, we'll have to FOIL these out or distribute. So we get x squared minus 5x plus 6. I'm going to leave my denominators the same. And x squared plus 4x. Oops. Sometimes I write quotation marks there just so I won't have to write it over and over again. So we'll go ahead and write it. Now we're ready to do the subtraction. We keep our denominator of x plus 4, x minus 2, and we subtract our numerators. So that's x squared minus an x squared, which is 0. Negative 5x minus a 4x gives us a negative 9x. And 6 minus 0 gives me a 6. I can factor a 3 out of there. So I'm going to factor out a negative 3, and that leaves me with 3x minus 2 over x plus 4, x minus 2. I didn't write the restrictions there for you so that you can get used to writing them. So our restrictions there would be -4, because that would make this one 0, and +2. There's our restrictions. None of those cancel, so I've finished. All right, here is another one that we're going to have to think even harder for this one, because before I can determine what's in my denominator, I am going to have to factor. Told you factoring was your friend with rationals. Once you have it factored, that's going to allow you to determine what needs to go into the denominator. For this first denominator, I need an x plus 3 and an x plus 2. And I did not give myself enough space there. There we go. X plus 3 and x plus 2, those are right there. For this one, I need an x plus 2 and an x plus 2. I've already got one x plus 2, so I'm going to need another one here. For this second one, I need an x plus 2 and an x plus 2. That's found right there. So that's our least common denominator. X plus 3, x plus 2, x plus 2. Now to get from the first denominator to our new one, we multiply times x plus 2. So I multiply the numerator times x plus 2. To get the second denominator to the new one, I multiply times x plus 3. So I'm going to multiply this numerator times x plus 3. You've got to do that so that you're not changing the equation. We distribute and we get x squared plus 2x. I'm going to go ahead and write my quotation marks there so we don't have to waste time doing that. And then 2x plus 6. Now we're ready to subtract. I keep, and I'm just going to write it as a square there since they're two of the same exact ones. So here is my denominator, I keep it, and then I subtract my numerator. X squared minus no other x squared is just x squared. 2x minus 2x is 0x, so that goes away. And 0 minus 6, don't forget you're subtracting that entire thing, so that minus has to go to everything up in the numerator. That does not factor, so that is my solution there, x squared minus 6. The things that would make it 0 are -3 and -2, so those would be my restrictions. We'll go ahead and try one more. So here's this one. I factor first. That's the difference of squares. Recognize that pattern because it's really going to help. Now we're ready. For our denominator, I need an x plus 2 and x plus 1, and I also need an x minus 1. So this part goes into here, and then both of these go into this part. They both divide into that evenly. So to get to my first one, from this one to this one, I multiply times x minus 1, so I'm going to multiply that numerator times x minus 1. For the second one, we multiplied times x plus 2, so I'm going to multiply that times x plus 2. Now we need to keep our denominator. Actually, now we need to multiply those out. So I'm going to have to distribute here and distribute here. And now we're ready to go ahead and combine these. X squared plus 2x squared gives me a 3x squared. Negative x plus x is 0, and then a -6. I have to write really small here because I left not a lot of room. That would be my answer right there. My restrictions would be no -2, no -1, and no 1. So that's adding, subtracting, multiplying, and dividing our rationals. If you went ahead and tried that 9, there is your answer if you want to check it. Our least common denominator was x, x plus 2, and x minus 2. We multiply this top times x, and we multiply this top times x plus 2, x minus 2, just x squared minus 4. When we subtract them, we get x cubed minus x squared plus 4. Now we're going to talk about solving, and you can only solve for what the x is when there's an equal sign. That's the reason why we didn't find what x was in those other problems. There was no equal signs. They were just expressions that you can put together to simplify. The only time you can find what x is when there's an equal sign. Anytime that you have one rational equal to one rational, that only happens when there's one on each side, you can cross multiply. In this case, you could not cross multiply because we've got two fractions on this side. And so we get x plus 4 times x minus 4 is equal to x plus 5, x minus 5. If you recognize those patterns, that's the difference of squares. So that's an easy one to multiply out. Now, in this particular case, when I subtract the x squared to get it to the other side, they cancel on both sides, leaving me negative 16 is equal to negative 25. That is not true, so this would be a no solution. That doesn't always happen when there's one on each side. You can get an x value, but in this particular case, this is what a no solution looks like. If it came out correctly, then you would be solving two quadratics like you would solve a quadratic normally. On this one, we've got three fractions. So the best thing to do is get rid of the denominators. Students don't really like fractions, so getting rid of them is the best thing to do. In order to do that, I need to factor. So we're going to multiply this entire equation times something that's going to make these denominators cancel. So x plus 2, x minus 2 is going to get this denominator to cancel. This one is going to cancel with an x plus 2. So I've got it right there. And this one's going to cancel with an x minus 2, which is also right there. So we are going to multiply this entire equation, and you have to multiply the entire equation on both sides of this equal so you're not changing the value, times x plus 2 over x minus 2, and all whole numbers are over 1. Remember when we were multiplying on the other side, if you had something in the numerator and the denominator, it canceled. So that's what we're doing there. When I distribute this to my first fraction here, this x plus 2, x minus 2 cancels the denominator, and this x plus 2, x minus 2 cancels the numerator. So all I'm left with is 2. When I distribute this to the second one, the x plus 2 in the denominator cancels this x plus 2 in the numerator. Now I have 3 times x minus 2 in the numerator and 1 in the denominator. So I can just write 3 times x minus 2. Then we've got the equal sign, and we're going to distribute it to the last one here. This x minus 2 cancels this x minus 2. And so we're left with 4 times x plus 2. We have now gotten rid of that rational part. We've just got a regular equation like you've been doing since pre-algebra. So it makes it so much easier to solve. I would distribute. I would combine my like terms. Now I'm trying to get the x by itself, so I'm going to subtract this 3x to get it to the other side of the equal sign. And so that gives us negative 4 is equal to x plus 8. And then I subtract 8 to get it to the other side. And there is my solution. In this case, I would want to verify that it does not make my denominator 0. Remember the restrictions here. X cannot be negative 2 or 2. So if my answer came out to be negative 2 or 2, it would be undefined, making it a no solution. But this particular one does not. Now you could always check it as well by putting it in there, and you'll see it's equal to each other. All right, the last two things we're going to look at is some word problems, and then we're done with adding, subtracting, multiplying, dividing, and solving rationals. It tells us, there's a typo there. Caroline can paint a room in 4 hours. It takes Rebecca 6.5 hours to do the same job. How long will it take them to complete the job if they work together? You remember speed. If you were trying to figure out your speed and you drove 300 miles in your car and you were driving for 4 hours, you would take 300 and divide it by 4. That would give you your speed. Well, that's what we need. We need Caroline's speed and we need Rebecca's. So Caroline did the one job in 4 hours. That's her speed. And then we would add Rebecca's speed. She did the one job in 6.5 hours. Now, the common mistake we see here is people just take 4 plus 6.5 and get 10.5 hours. That doesn't make sense. because one person did it in 4 hours, why would two people take 10.5 hours? So think about what you're writing down when you do these word problems. They're working together, so I'm going to add them, and they're still doing the one job, and we want to know how many hours. So that's our unknown. That's what I would put the X in. And then you would solve this just like you did up there. You would want to multiply times 4 times 6.5 times X. That's what's going to make these cancel. When I multiply it times the first one, we get 6.5x because the 4's cancel. When I multiply this times the second one, I get 4x because the 6.5's cancel. And when I multiply it times the third one, the x's cancel. So I get 4 times 6.5, which is 26. I combine my like terms and I get 10.5x, and then I divide by 10.5. And so 26 divided by 10.5 is 2.5. Again, if this gave me something that would make any of these denominators 0, it wouldn't be a true solution, but it didn't in that time. All right, it says you travel 10 miles on your bicycle in the same amount of time that your friend takes to travel 8 miles. If your friend rides his bicycle 2 miles per hour slower than you ride your bike, find the rate at which each of you is traveling. All right, back in Algebra 1, you learned that equation distance equals rate times time. So your speed times your time is going to give you your distance. We're going to use that equation, but what we know is that they are the same amount of time. So I want to get the time by itself. So we divide by r. And so that's distance over rate is equal to time. So you travel 10 miles and your friend travels 8 miles in the same amount of time. So I can set them equal to each other since it's the same amount of time. So our times are the same, so I could set them equal to each other. Now for your rate, you don't know how fast you were traveling, but you do know that your friend goes 2 miles per hour slower than you. So your rate is going to be x, and your friend's rate would be x minus 2. Those are our unknowns. That's what we're looking for. So here is 1 fraction is equal to 1 fraction. So the easiest way to solve this one, cross multiply. So we get 8x is equal to 10 times x minus 2. We distribute. I subtract the 10x to get it to the other side. We divide by -2. You can't see that. And so x is equal to 10. So that would be your speed. Since we defined x as your speed, you would be traveling at 10 miles per hour. If we wanted your friend's speed, that would be 10 minus 2, which is 8. So now you've seen adding, subtracting, multiplying, dividing, and you saw some solving and some solving real world problems.